Hi, this is Geek and I'm Dan, and this video is me machining the X-axis carriage bits. It's difficult to know exactly where to draw the line. Basically, this is connecting the X-axis ball screw to the linear rails, kind of bearing blocks, and creating a surface mount point for what will be the Z-axis. So I machined a bunch of parts, and we'll cue the video montage of that now. Classic bit of fly cutter action is to clean up my stock on all sides. I was getting a little bit arty here. Molten Make put out a 1-minute video challenge, and I was in the middle of doing this project, so I kind of lent into that a little bit. It's fun to use the robot cameraman a bit more. Basically, this operation, say I had a couple of these identical sized aluminium blocks, drill a bunch of holes in the same pattern as the carriage blocks on the linear rails are, so that they can be screwed on. I was very excited about this countersink bit, getting all fancy with it. Only later did I realise that I made a mistake, but we'll talk about that in a minute. Once I drilled the hole patterns, I had to flip it up, and I need to make this recess a specific dimension. A lot of checking with the calipers, and later on, in order to allow the ball screw to not foul on the top corner, just a bit of a ball-ended end mill to create this little cove. Then on to the main brackets for the actual ball screw nut. So you can buy them with, but I needed something custom, and here we go with the boring head in order to get that exact dimension. This is a really cool tool, I really like using it. And this is where having a DRO comes into its own again. I needed a specific hole pattern for the screw attachments to the ball screw nut, which is basically 6 out of an 8 hole pattern. So yeah, with the DRO, you just on center tell it you want 8 holes, and they need to be a certain diameter apart, and away you go. Just find the positions. I was putting bolts in as I hit each position. I had to move the parallels to get me those top and bottom holes without being messed up, but worked great. Kind of get the idea. Lots of operations, easily the most complicated bits that I have machined so far, given that I needed to machine them kind of on this particular piece, machine on all sides, create recesses. I screwed up a few times. I have some holes that are in the wrong place. Basically, I expected some holes in this center section offset, but I drilled them after I drilled the counterbores, and given that they were not central, they were kind of skewed to one side. What I neglected to take count of is that they should have been drilled the other way up. So I had decided to compensate a little bit, rather than destroy the part and start again. I just sort of shifted things as a little bit of a gouge out, where I kind of have to make a bit of room to be able to shift it slightly over. So be it. I also have, if you can see, there's just a little recess along here, because the design I came up with, I wanted to try and keep the ball screw as close as possible to the linear rail without being really difficult to work on or really in the way, and give myself enough room to also create connecting points without screwing into things. That's a little bit of a complicated way to say, but the design is that this kind of sits up against here. Let me just bring you in. So what we have here tucked in there's the lead nut is connected by these little brackets, and then this will sit on top of the pillow blocks of the main axis. So this connects on like that. So this screws into these brackets, and then these screw down into the pillow blocks. This whole assemblage, I made 2 of these. We have some making up pieces. I'll talk about that in a second. But I didn't want to make this out of a big chunk. So let me just grab. This is the lead screw for the Z-axis, and this big old block of aluminium here came with this whole setup because I bought them all as a kit. And in this case, this is exactly what it needed. There will just be a surface mounted on here, so it seemed sensible just to grab it all as a kit. That's fine. But for this use case, I didn't have enough room to have a block like that and bring this that close to the back surface of the carriage. And rather than buy a big chunk of like 30mm aluminium or whatever, I decided to make it as 2 separate plates with these brass spacers. So the brass spacers are all exactly 10mm. Just knock those up on the lathe off camera. And I've just received, so I kind of tacked sort of 3 in because I only had 3 of the right length screw. These have just arrived, so I can now kind of pop out these that we're just retaining. Let's see if I can. So you can see simple brass bushing kind of thing that just lets me maintain that 10mm spacing, and I can kind of have the effect as if I have a thicker block in terms of resisting the torque and whatnot. Right, there we go. So I'm just going to pop the correct in. So I guess I should also point out that this guy has just M5 clearance holes, and this has threaded holes. So we're basically pulling this block up against everything rather than trying to keep threads in both sides, which I think would have been not very workable, basically. Right, so let's take that one out and slide this guy in. So this was my idea for making a custom kind of attachment block to this, the ball nut itself. And as you saw in the machining, relatively easy just to bore a nice precise hole and create the hole pattern for these mounting points. Very straightforward with the DRO. Now, where I got into a little bit of difficulty, and hence the making up piece, is the exact depth from here to here, or I guess more accurately the reference point between this surface, this center line, and where the pillow blocks are based on the thickness of this. One of the challenges in all this is my original design assumed that my 10mm aluminium was 10mm. It is not. It is slightly under 10mm, and by the time I've surfaced the faces with the fly cutter, it's about 9.1-ish. And when I made the first piece and I fitted it up, I realized that there was it wouldn't kind of sit flat with the pillow blocks. Hence, the second piece, I compensated for that. It's about 1mm of extra width here, and I just have a couple of bits of steel offcuts from something to make up that 1mm padding so that I can kind of bolt this down. So this fella comes on like this. Let me just get these in place. So the idea is that the order of operations for all of this is going to be quite important. in terms of how to connect everything up securely. Let me just tack these in place for a second. Right. So this whole assembly should give me a pretty solid mounting between the drive power coming through the ball screw and the linear bearing blocks. So I'll go and mount that properly in a moment. Let's just tighten all of these up. So as part of figuring out this whole spacing as well, obviously we could reference off the ball dart side, but then this wasn't 10 mil and I drilled these holes 5 mil from this face knowing that it wasn't 10 mil, but then with a 10 mil spacer I then also had to compensate for the odd size in order to get these right. It was a bit of a faff. Then we also have threaded holes drilled in the front surfaces here. These have to obviously avoid the cross holes for the pillow blocks, and these holes have to avoid the mounting holes that come up from the bottom. So there's a lot of just trying to figure out how to keep the package small and sturdy whilst avoiding kind of clashing with anything, and also giving myself the correct order of operations to be able to build it all up. And what you probably see on this is that one of these holes is not in line with the other, because the first one I referenced 5 mil from this face when it should have been 5 mil from this face, and so I'm having to compensate for that. The good thing about doing this sort of on the fly as I go is that I can compensate for these things as I come along. Okay, let's get this mounted on the machine. Let's go over here. So what you can see is I already have just a temporary faceplate here, and I need to make another one of these, but for now I should be able, if I feed that through there, and that onto there. Okay, so let's just make sure we've got everything in place. Right. That'll do for there for the moment. This guy holds us in at the other end. Let's just... So hopefully that is holding the whole lead screw sort of in the alignment I want. And you can see this is what I'm talking about, that I wanted the ball screw to be pretty close in without... There's not really enough room to go between these without getting very cramped and difficult to make. Or making this even taller. I didn't really want to do that. So we'll see how this pans out. Hopefully I can drop that, a couple of these mounting holes in place. So there's a lot of delicate measurements in all this, because I mean the pillow blocks themselves will rock on this, but ultimately these faces all need to be parallel with the faces on this one, and obviously secured, and it's a bit fiddly. Right, that's kind of just secured this with a couple at each end, and now hopefully this all lines up. So I say this is just a quick tacked in place situation. So this is where I talked about the fiddliness of alignment. In my theoretical CAD model, the offset of these to these is just ever so slightly off, and you can kind of see that this doesn't want to be quite lined up. I expect that means the real model these are shifted slightly this way compared to where they should be, because I'm not perfect. But this is good enough for now to kind of, yeah, show the point. And if I grab this, we can do a very quick test. There we go. So I think that's probably it for this video. Another couple of complicated parts made. I can adjust the plate to compensate for how I didn't do very well in the first part. But again, that's the advantage, I think, of making this as I go along, so that each next part can account for the reality of the previous part rather than the CAD theory, which assumed that I would be perfect. And then ultimately this is going to sit on here, centered, so I have another design version of this to laser out, which includes the mounting holes for this, and these holes here are already geared up to take the Z-axis linear rails. And as always, it's now going to be a real case of how do I attach these things. So this is the actual plate that will be here, and I can thread into this so the mounts can just screw straight to it, but part of me wonders whether that will be enough threads to be strong enough for some purposes. So particularly this, which was going to be the bottom of the Z-axis, only has these 2 mount points, and if they're just threaded into this like 4mm steel plate, is that enough threads for a high torque maneuver? We shall see, because I don't think I have enough room behind here to, I mean, I might, maybe, yeah, tricky. Anyway, that is the the X-axis carriage primary construction. The plate is kind of hard, the X-axis. I haven't done that yet, but I still need to machine that square, and I need to figure out the layout in collusion with the Z-axis. So it is what it is. It's coming along. It's starting to look like a CNC machine. I still need to worry, obviously, about the Y-axis drive, but I think that's going to be, he says, jinxing himself horrifically, I think that's going to be much easier, just because there's a bit more room to maneuver. This is the conflagration of more complex requirements, and obviously this is where all of the actual torque happens, and so I hope that this design will provide a very rigid base for the router to sit. So that's that. That's it for today. Thank you for watching. See you next time.